So far, we've been mostly talking about defining locations in the plane, and we've talked about defining locations in terms of Cartesian coordinates and also with respect to polar coordinates. But of course, there are a lot of different types of vectors. Location is one thing that you can talk about sort of using vectors, but you can also talk about velocity using vectors, you can talk about forces using vectors, you can talk about fields using vectors, you can talk about accelerations using vectors. And in fact, all of those quantities, including position, are quantities that might change in time. They might also depend on where you are. And so in fact, they're not simply static vectors that you would talk about as 3 times I hat plus 4 times j hat. They're actually vector valued functions. So we're going to spend a little bit of time talking about vector valued functions and how we might think about those. And in talking about vector valued functions, I'm going to divide that into sort of 2 broad categories. Right? One category is vector valued functions where the function is a vector. Right? So I have some function f that's a vector, but it's simply a function of time. Right? So an example of a vector valued function of time would be something where you said, okay, I've got some particle that's moving, and since it's moving around, its location in space, or its position vector r, is changing as a function of time. Right? Now, another example of a sort of function which is vector valued, but it's a little more complicated, is the idea of a vector field. And this is something we're not going to deal with very much in this class, but I think it's worth highlighting at this point. You can also have a vector valued function that depends on, say, where you are in space, and could also depend on time. So an example of that might be saying, okay, well, I've got a river, and within this river, the velocity of the water at different locations is different at different points, and maybe at different times of year as well. So for each point in the river, there is a vector v that tells me what the local velocity is of the water, but that vector v depends on where I am and also depends on time. So I'd say there is a velocity field or a vector field of velocity that tells me about what the characteristics are of this river. And finally, I'll note that sort of you could contrast vector fields with scalar fields. If you think about what a scalar field would be, well, a scalar field is simply going to be some scalar function, some number, but some number that might depend on position and might also depend on time. So a good example of that might be, say, temperature within a room. So I've got a room. Over here I have my fireplace. That's a flame, really. And some, person comfortably relaxing in front of the fireplace on an artistically drawn chair. And if you think about what the temperature is in the room, well, the temperature is going to be quite warm by the fire. And then maybe over here by this window where there's cold air outside, the temperature might be quite a bit colder. So here, temperature is hot. Here, temperature is cold. So you can imagine the temperature might be a scalar field, which would depend on where you were in the room, the position that you're at, and also would depend on what time of day it is, or how much wood you put on the fire, or whatever else. So there are a lot of different ways to sort of think about functions, both things that are functions of vectors. So fields are cases where you actually have some function that depends on, say, where you're located in space, and also vectors that are functions either of time, or they can also be functions of space or functions of other vectors. Okay. So we've at least defined hypothetically what these are. Of course, the things that you're probably most used to dealing with are vector valued functions of time. So position is typically a vector valued function of time. Velocity is a vector valued function of time often. Acceleration is a vector valued function of time as well. And I think the next thing that we probably need to talk about is how to actually deal with the combination of vectors and calculus. So next is integration and differentiation of vector valued functions.